This is our second video over momentum, and we're going to cover impulse for a little bit longer. An impulse is the product of force times time, meaning that if we take force and multiply it by time, we basically have the amount of time that an impact occurred or a collision occurred, and we call that an impulse. It's a time frame in which a force was acting on an object for a collision. So our equation for impulse is force times time, and that also equals the change in momentum for the object. So if we have an object that is going into a collision, that collision is going to have a force. The object is going to hit another object or a wall or something like that, and it's going to exert a force on that wall, and the wall will exert a force back. So there is a force applied there, and it happens during some time frame, and that's going to cause the object to change its momentum. So that's why impulse equals force times time, and that's how we know it, but it also changes the momentum of an object. So how we're going to look at this is we're going to have a ball that is 10 kilograms traveling at 10 meters per second toward the wall. The ball hits the wall and stops. It's going to stick. It's going to stop. So the final velocity will be 0. So when we solve this, the change in momentum will be equal mass times the change in velocity. So we have a 10 kilogram object, and it has a final velocity of 0, an initial velocity of 10, so 0 minus 10 because the change in velocity is final minus initial. So that will come out to a negative 100 kilogram meters per second. The ball hits the wall and stops. That's what's happened. No matter what happens, this is our change in momentum, no matter what we do. When it comes in with 10 meters per second and it stops, its change in momentum will be 100 kilogram meters per second. So now we can talk about how it stops quickly and how it stops slowly. So we're going to look at example 1 where it stops quickly, choosing a time of 0.01 seconds. Using our equation, where impulse is equal to both of these things, force times time and change in momentum, we can do force times time equals the change in momentum. And we divide both sides by time, to where we have the force equals the change in momentum divided by time. So that is negative 100 kilogram meters per second divided by 0.01 seconds. So the seconds will cancel. I'm sorry, the seconds will not cancel. The seconds will square. And we end up with 10,000 newtons, which is kilograms meters per second squared, which is a newton. In this situation, we had a very short time of collision. So the collision happened very, very quickly. There was not a lot of time occurring for the force to be exerted on the object from the wall and the ball on the wall. So a short collision results in a very, very large force, where force equals change in momentum over time. If you decrease the amount of time, the force will increase. They are inversely related. Looking at this a different way, as if it stopped slowly, our change in time is going to be a bigger number, so 0.1 seconds, which happens to be 10 times longer that the force was able to act. So that force happened over a longer amount of time, and so we're going to use the exact same equation. We've already divided by time, so force equals the change in momentum over change in time. And it's negative 100 because our change in momentum is the same. No matter what we do, it's negative 100 kilogram meters per second. And we're going to divide it by a greater amount of time, so 0.1 seconds. And we get 1,000 newtons, which is 10 times less force. Which should make sense. If we happened it for 10 times longer, it should, since it's inversely related, force and time are inversely related, it should be 10 times less. So extending the time of collision decreases the force. They're inversely related. If you have the force acting on the object for a longer amount of time, the force is lessened. The change in momentum is the same. So let's look at it graphically. So first off, impulse is the area under a force versus time graph. So if we have a curve or a line or a shape of some sort on a force versus time graph, the area under that shape or line or curve or whatever the case it may be will be impulse. This graph shows a very short amount of time and a large force. So you can see that the time was, if we counted each box as a second, the time took approximately 6 seconds, and our force was very large. If we do the exact same change in momentum and increase the amount of time it took, you can see that the force is less. So by extending the time, the same collision has less force. And we do this often. Like if we jump and we bend our knees when we land, it allows us to have more time to land. We don't land don't land very fast and stop very, very quickly. We were able to slow down the time it takes to stop. But things that we employ for safety, like airbags and bumpers on cars and helmets when we ride a bicycle in case we fall, those things are there to increase the amount of time of the collision that occurs, thereby lessening the force that is caused in that collision. So you can see if we have a short amount of time, the force is increased. If we extend the amount of time the collision occurred, our force is decreased. That's the main concept here with impulse. It changes the momentum no matter what. The same change in momentum is going to occur. But no matter what, if that stays the same, the best way to save lives, for example, is to increase the amount of time that collision occurs so we can lessen the amount of force. Airbags, bumpers, helmets, crumple zones, bending knees when landing, things of that nature. So this is another way to look at it. You'll have a little bit more practice over this in class before we take our quiz. But feel free to come in with questions.